find the value of z if the area under a standard normal curve to the right of z is 0.3785. So you know that the areas given in normal curve are always on the left of z in the SOA tables. So we will say that area to the left of z, so we'll convert the right area to a left area. Area to the left of z is equal to 1 minus area to the right of z is equal to 1 minus 0.3745. So 0.6255. So in the normal curve, we look at that z value, which corresponds to the cumulative area, cumulative probability of 0.6255. So the areas in normal curve are actually probabilities. So we look 0.6255 in the area region. So the main thing is you need to convert it into a left area as we did here. So let's look at 0.6255. So 0.6255. So you have to search for 0.6255 in the area region, and here it is, and that corresponds to z equals 0.32. Okay, so our z value here is 0.32. Now we have area to the left of z is 0.1271. And now here we have an interesting situation, because if you look in the table, you won't find 0.1271 because these areas start at 0.5 and then go all the way up to 1. And the reason for that is that these are for positive z values. And for positive z values, they have to be these, because when z is 0, then the area to the left of z is 0.5. And then as z becomes positive, that area keeps increasing. So what we need to do here is, so we are looking at area on the left of z is 0.1271. So this is the picture. Now area on the left is 0.1271, and that means it's kind of this kind of an area. And the z value that's here is a negative value. And that's why we have to somehow see how to translate it into a positive z value situation. So this area on the left of z is 0.1271. So the area on the right is the white area. So that is 1 minus 0.1271. So that would be 0.8729. Okay, area on the right of C is 0.8729. And now this is the same area if we were to take a value here. So let's call this as negative z. So if we were to take a value of positive z, which means the mirror image of whatever this negative value is, and you consider area on the left of it, that area is the same as this white area in the figure above by symmetry, because this white area was on the right of this. So on the left, the corresponding positive z value, we should have the same area. So this area is 0.8729 as well. So now this picture is telling us that what we need is this z value that corresponds to an area on the left of 0.8729. So which corresponds to an area of 0.8729 on its left. So if we look at 0.8729 from the table, we get 0.8729. So that corresponds to z equals 1.14. So z equals 1.14. So this means this is equal to 1.14. And now from the picture above, we were looking for this z value, and that's just a mirror image of this z value. So that has to be negative 1.14. So negative 1.14. Okay, and now we say area between 0 and z is 0.4808. So once again, remember 0 cuts off half of the area, or 0.5 of the area. And now we're talking about 0.4808, and that's so they're telling us it's a positive z, so area between 0 and that positive z is 0.4808, so it's this one. This is the z, and the area between 0 and z is 0.4808. Okay. So the way the tables are, they do give the areas to the left of z values, but they give them all the way up to left. So we know that this white area is 0.5. So the area on the left of z, remember, to read the normal table, you have to look at an area on the left of a z value. So let's just write area to the left of z equals this 0.4808, which is from 0 to z, plus the 0.5, which is on the left of 0. So it's actually 0.9808. Okay, so this is the area we are now looking at, and that will give us this z value. So 0.9808. 0.9808 is this one, so 2.07. So z equals 2.07. Right? Okay, so now we have area between negative z and z is 0.9500. So between negative z and z is 0.9500. So this area is 0.95. And now the white area above, the white area equals 1 minus 0.95 equals 0.05. So white area would be this area plus that area. And we just want half of this area. So white area on left equals half of the total white area, 0.025. So that's this one. And the reason why we calculated this is because we need area all the way to the left of C. So now we can see from the figure that the area all the way on the left of Z is this one plus this white area. So area on left of Z is equal to 0.95 plus 0.025 equals 0.975. So now this is the area we'll look in the table. And that will give us the Z. 975. 9750, so that's 1.96. So Z is 1.96.